How many seconds did it take to make that?
B made it.
How many seconds did it take to make
They used to have like a iPod on it or something.
I don't know if there used to be an attachment or what, but I asked Mrs. Sheffa if she had one. And so she had a tripod, but not that. And so somebody said they would bring it up for me, and they did. So that's what we're with. Okay, today's the 7th. We're doing section 1.8, combinations of functions. Composite functions. Hopefully this is a little bit of a refresher break from the graphing and you remember most of this stuff. There really isn't much new to you in this particular section. Okay. Sum or difference, sum comma, difference, product, and quotient of functions. Determined to make it fit. One letter short. One. Sum f plus g of x.
Oh.
Here, we'll go colon. I'll put a little colon there. F plus g of x equals f of x plus g of x. Difference. F minus g of x equals f of x minus g of x. Okay, now, I'm going to put something in parentheses here. Use parentheses around g of x. We have to have parentheses around g of x because if g of x has more than one term, the minus sign has to be applied to all of g of x. So if we use parentheses, hopefully we will remember to distribute that negative to everything. Product. F times g of x equals f of x times g of x. Quotient. F over g of x is f of x over g of x. And what do we have to make sure we say? What information do we have to include about this quotient?
Negatives in the denominator.
Oh, we can have a negative in the denominator. What can't we have in the denominator? 0.
Darn.
If you have a negative in the denominator, you just move it up top, right?
Yeah.
So those are the rules. Now let's apply them. Anybody still copying? Example 1, given. How many of you remember panicking when you saw given in geometry because you thought a proof was coming? Anybody?
I know what those words mean.
Find f plus g of x and f minus g of x. Gotta stop doing that in 40 minutes.
What, Randy?
Uh-huh. Because I have to go get my lunch. Okay, so we know f plus g of x is the same thing as f of x plus g of x. So 3x minus 1 plus x squared minus x minus 4. The notation, be very careful because we're going to do composite functions also. Pay attention to the symbols, okay? So this says add, so you add, okay? I know that sounds silly for me to say that, but when we get into composite functions where we put a function inside another, that's different. So we really want to pay attention to what the notation is. When we combine like terms, we get x squared plus 2x minus 5. Good? F minus g of x is f of x minus g of x, 3x minus 1, minus, remember I said use parentheses so that you remember to distribute that negative to everything that is g of x. So this turns into 3x minus 1 minus x squared plus x plus 4. You can skip this if you wanted. You don't have to write this. Then you could just do the math if you wanted in your head, but just be careful. Minus x squared, 3x plus x is 4x. Negative 1 plus 4 is plus 3. Good there?
Yeah.
Okay. Example 2. Given f of x equals x plus 5 and g of x equals 3x, find f times g of x. Good? Okay. Example 3. given f of x equals x plus 1 and g of x equals x squared plus 3x plus 2. Fine. F divided by g of x and g divided by f of x state the domain of each. So one step you could skip is right off the bat, instead of copying g of x, you could factor it if you wanted to skip that step and go straight to this. Good so far? What happens to the numerator? Huh? Yep, becomes a 1, don't forget. It doesn't disappear. Now we have 1 over x plus 2. What's my domain in interval notation?
Parentheses, negative infinity, comma, negative 2, parentheses. Union, parentheses, negative 2, comma, infinity, parentheses.
No.
Good so far.
What can't you? What else can't
You have to go back to your original function to state the domain,
you?
okay? Well, we talk more about this later, but okay, so now what's my domain? What else can't x equal according to my, without canceling? Negative 1. Okay, keep going.
Union, parentheses, negative 1, comma, infinity.
Yeah, so our original function, f over g, g can't equal 0. G is going to equal 0 at negative 1 and negative 2, okay? So the x plus 1's canceled out. When we graph rational functions, this x plus 1, x equals negative 1 will be a whole, okay? It still has to be removed from the domain. Okay, now we're going to flip it, do g over f. I'm going to go ahead and factor it since we've already done it once.
Parentheses,
Okay,
negative infinity,
okay,
comma. Negative 1,
uh-huh.
parentheses, union, negative 1, infinity, parentheses.
Good. Yeah, you got to come back to this original function to get domain. Get domain before canceling. It's one way you could think about it. Okay, on to composite functions. These are my favorite. Fog and Goff.
That's like f of g of x.
Uh-huh.
Oh, I like.
What
Yeah.
is it?
composite. Composite functions. Okay. The composition of two functions F, open dot, G. Not multiplication. Not multiplication. A lot of kids call this fog, and when you do G of F of X, they call it goff, fog and goff. F of G of X means you have your function F of X, and you plug G of X in everywhere you see X. Okay, the domain of F of G of X is the set of all X in the domain of G of X such that G of X is in the domain of F of X. Isn't that beautiful?
It's very confusing.
It is. It's one, and I've told you, college algebra is not my favorite thing to teach. This is probably the least favorite thing to teach in college algebra, is the domain of composition of two functions.
What does it say?
So when you go to get the domain of this, first you have to look at the domain of this.
Okay.
So we look at the inside function, but we have to make sure that everything in this domain is also in the domain of this outside function.
Okay.
Yeah. So that all that's in the domain of G, so we want to get the domain of G of X first, and then make sure that all of that is in the domain of F. And then you start removing values if you have to. Yes.
Why doesn't it just say that?
Well, it kind of does. It just says it very confusingly.
It does not.
Okay. Example 4. Given f of x equals 2x minus 3 and g of x equals x squared minus 1. Find f of g of x and g of f of x. I spaced mine out really far so people don't think it's multiplication. You don't have to have them spaced out that far. It's just how I do it. Okay, so we want to do f of g of x first. So it says f of g of x. So wherever I see an x in f, which is right here, I have to replace it with whatever g of x is. So another way you can write that is f of x squared minus 1. And we know that whatever is in here goes in for x. in the f function. So we would have 2 times x squared minus 1 minus 3. And then you want to distribute, combine like terms, and simplify it. So the problem didn't ask for domain, but let's just go ahead and talk a little bit about the domain. First, let's look at the domain of g of x. What kind of function is g of x?
Quadratic.
Quadratic. What's the domain of a quadratic function? Okay, let me ask you this. Is there any restriction on the domain?
No.
No, there's no restriction on the domain.
Negative.
Yes, negative infinity to positive infinity. Now, are there any restrictions on this?
No.
No, because it's what kind of function?
Linear.
Linear. So there's no restrictions on this. So there's nothing in this domain that's not in this domain.
So negative infinity.
Yes. Yeah. What's up? I need Kenny.
Wait.
Oh, he said he had to go at noon.
Yeah, he wanted to skip the class.
No, I know he wanted to skip my class. Her name's Maddie.
Curtis?
Nope.
Oh. I said, Ken, what class do you want to get out of? He's like, oh, Miss Thomas. I said, I'm moving too fast.
Okay, now we're going to do g of f of x. Kenny, I'll post them. Okay, g of f of x. So now we're going to do g of f of x, and that's going to be g of 2x minus 3. And I should probably do this on the next page. Oh, maybe we have enough room. I'm just going to work underneath though. Okay, now wherever we see x in G, and there's only one place we see it, right there, we have to put 2x minus 3 where we see x in G. Okay, 2x minus 3 squared minus 1. How do we do 2x minus 3 squared? What's the trick? What's the quick way?
Square.
Square it. 4x squared.
And then multiply them and double it.
Multiply these two, double it. So negative 6x, negative 12x, and
Square.
square. Good? Okay. This is where the real fun begins. Anybody still copying any of this? Okay. Now let's add some challenges.
Oh.
Given f of x equals 1 over x minus 2, and g of x equals the square root of x. Find f of g of x and state the domain. So I'm going to let you work on this one for a minute by yourself, and then we'll do it together. So what is the domain of g of x?
It is, oh wait, I have it. It can't be negative.
Right.
So it's, bracket, 0,
Bracket 0.
comma, infinity.
Okay, now, but f of g of x,
Yeah.
what is the domain of this? We know what about this denominator?
And
Be 0.
It can't be 0. So we know, in fact, I'm not gonna use equal signs, I'm gonna use an arrow. So we know the square root of x
So it can't be full.
minus 2 can't equal 0.
So
X
x cannot be full.
cannot equal 4. So now what's the whole domain for the domain of f of g of x?
Full. Parentheses. U. Parentheses. Full. Infinity parentheses.
Yeah. Okay, one more example, and then we're done.
yes. Yeah.
Any questions so far? Feel good? No? Why not? Because you gave blood?
And my head
Oh, was that you that said, I thought that was Colin that said you doesn't feel good. Is it because you gave blood?
hurts. I don't know.
Did you give blood?
Yes.
Where's your thing at? You don't have it on? Oh, okay.
He's
Did you
left-handed.
eat?
Yes.
Do you need another snack? Because I have fruit snacks in there.
I'll go back.
Oh,
Okay.
don't sound like you're left-handed.
I did.
I just have a headache.
I apologize for laughing so much.
It's okay.
You didn't give double, right?
Who?
Grayson.
It was like one.
I couldn't handle getting,
Not that bad.
Did you give double Jacob?
Yes, sir. You got the double next time.
I wouldn't if I were you.
If this is how 1 is affecting you guys, it's kind of insane.
Yeah.
But you are drinking water, right?
Oh, yeah.
Do I have to worry about you passing out right now?
No.
You sure?
Yeah.
Okay, you have good color in your face right now, so I'm happy with that. Yes?
Instead of writing log, can I just write the f of g of
Uh-huh.
x? Okay.
I like
I'm gonna read it as fog 3. I'm like, what am I saying? What is
No.
fog?
I read it.
My brain doesn't work
It
with
doesn't
that number.
compute that way.
I apologize for laughing again.
Okay.
Wait.
So what do we do?
You plug for g of x, you plug all x's in for 3.
Yes.
Yeah,
Yeah, so what we're doing is f of g of 3. So I can take g of x, or do g of 3.
Wait, what? Oh, so where X is, you're plugging in 3.
And yeah, just into G. I'm gonna do it 2 ways, and then you can pick which way you like better. Okay, so this is 29.
Yeah.
Then I have to do f of 29. And I get 29 minus 1.
20.
I get 28. Okay, now here's the other way you can do it. You could do f of g of x. You could do f of g of x, and you would get 3x squared plus 2 minus 1, which would be 3x squared plus 1. Right? So take f, put g in. So that's 3x squared plus 2 minus 1. Simplify it. Then you could do plug in 3. So then you could do f of g, it's all the same thing. So it would be 3 squared plus 1. 27 plus 1 is 28.
I'm gonna start the first way thing.
Yeah, so it doesn't matter which way. But people do it both ways. I check both are correct.
Nice.
You can keep
Okay, so that's everything. Here's your homework.
I think I looked it
I actually like this. This isn't bad.
up. Yeah.
I told you, this is a refreshing from graphing. This is a nice refresher, little refreshing break from graphing. Okay, page 89 to 92, 7, 9, 11, 12, 13, 14, 17, 19, 21, 27, 35, 36, 55, 56A, 59, 60, and 73.
Why do you hate me?
I wrote this assignment out years ago. Must be the same assignment I use most years. So I'm sure some of these are very easy.
Can I take a picture of this?
Yeah, I'm gonna post it to Google Classroom too.
What?
So either way.
It's like a lot of numbers.
Wow.
Again, I apologize not being so